Okay, what I'm going to be doing today is showing you how to do two things. First of all, I'm going to be showing you how to do some recoding. You'll be using recoding when you want to regroup variables according to certain criteria. Like, let's say you want to categorize all people who've never been married into one category and everybody who's been divorced or separated into another category. I'm going to show you how to do that, and then also I'm going to show you how to run an ANOVA today. But we'll start just with the recoding part, and before you even start to think about recoding, what you need to do is look at your hypothesis. Now, in this case, I've just kind of drawn up a random hypothesis just based on my gut without any literature review. And as you'll see later in this demonstration, doing that is usually a bad idea because you tend not to get very good results, which you'll see. So for hypothesis 1, I'm interested in differences between different kinds of single people. So I'm thinking that there's going to be some kind of difference in the depression rates of people who are divorced or separated, so basically in the marriage dissolution state of their lives, and then there's going to be a difference between that group and those who have never been married. Okay, so unmarried individuals. So to restate that, I'm just throwing it out there that maybe people who have gone through a divorce or are currently separated are going to have a higher mean depression score than people who have never been married. And so you can see that I've written my hypothesis here down, and then I've written my null hypothesis down, and you don't have to organize your stuff this way in your reports, but it can be helpful for working on your report. So what I've done here is I've written my null hypothesis, which is always that there is no difference between the means for your two groups. And I've said that the divorced and separated mean depression score is going to be equal to the unmarried mean depression score for the null hypothesis. The alternative hypothesis then is that the divorced and separated mean depression score is going to be greater than the unmarried mean depression score. And then I've noted that this is a one-tailed positive direction test. The number of groups I'm comparing is 2, and so the appropriate test is probably an independent sample t-test or a 2-group t-test, 2-sample t-test. If you look below, I've kind of started my recode section on this, and here I've gone ahead and noted what the values for the marriage variable in my homeless persons 161 data set mean. So a 1 on the marriage variable means the person is married. A 2 means that that person is divorced. A 3 means that that person is separated. 4 means that person is widowed. And a 5 means that person has never been married. So before I do any recoding to test my hypothesis, I'm going to want to run some descriptive statistics, as I usually am going to want to do. So I'm not going to need to do anything else except run frequencies, because this is a categorical variable, meaning it's nominal or ordinal. So let's look at the marriage status variable, which is right there. So I just need to put it in the frequencies variables box and then click OK. And my output should show me the frequency for all of my marriage categories. So a couple of things to note here that are going to be important for your recodes. First of all, you'll notice that 2 groups have really low frequencies, which is why I decided to leave them out of the hypothesis I'm doing. Now, your first statistical report is probably not going to be as detailed as the one I listed, but once you start to explore the data, you may realize that you have groups you can't use, or that you may need to group some people together. So I'm looking at married people and realize there's only 7 of them, so I can't really compare them to anybody else in the group. And I also have set 5 widowed individuals, which means I can't really compare them to anybody else in the group either. However, I've got 83 never married people, which is about 51.9% of the sample. And then I've also got 43 divorced people, or 26.9% of the sample, and 22 separated people, or 13.8% of the sample. Now, I could just keep the divorced, separated, and never married categories, and then look at differences between those three groups. However, that would require me to do an ANOVA test, or an analysis of variance. And perhaps I don't want to do that. Maybe I just don't think that there's really that big a difference between people who are divorced and people who are separated. There could be all kinds of reasons I might not want to do an ANOVA. In this case, my hypothesis is called for a two-group comparison between those who are either divorced or separated, and then those who have never been married. So what I want to do is I want to create a variable where those who are divorced and separated are coded as one group, and those who have never been married are coded as the other group. And this is surprisingly easy to do. Okay? So bear with me. Now, you'll notice that each of these values has a different label, and so I can see that 1 equals married. Well, I'm not going to be using that group in my analysis, so when I recode that variable, I want to delete people out of the variable who are married. Okay? Now, people who are divorced have a 2 for their score on the marriage variable. I want to keep those, but I want them to be in my 1 group. And the way I decide what my 1 group is going to be when I'm doing a 0, 1, or dichotomous variable is usually the people I'm looking at as having an effect or being greater than the other group go into my 1. There's a lot of ways to do it. That's just kind of the way I do it. So people who are divorced, I'm going to recode as a 1. Then people who are separated, I'm also going to recode as a 1. So when I've recoded my variable, people who are divorced and separated will have both been recoded into the 1 group. Okay? Now, people who are widowed, I'm going to delete out of that variable. And then those who are never married are going to be coded as a 0. So ultimately, what I should end up with is a new marriage variable where the 1s are either divorced or separated, and the 0s are never married. And then I'll be able to compare those two groups. So let's look at how to do that recoding procedure. It's really easy. You just click on the Transform tab, and you're going to go down to Recode into different variables. Do not use recode into same variables. What that will do is it will replace the variable you're recoding with the new values, and that's going to keep you from being able to ever look at that variable again in this data set, so don't do it. Instead, go to Recode into different variables, and I've already done some things, so I'm going to click Reset. Now, the variable I'm starting with, in other words, the variable I'm recoding, is marital status. So I'm going to click the arrow to make that the variable I'm changing. I'm going to have an output variable. This is the new variable that I'm creating. Okay, that's going to contain my recoded scores. I'm going to name that variable marriage recode to show that this is the variable that I'm creating from the original variable. Once you've done that, you put in the name, and for the label I might say 0 equals unmarried, 1 equals divorced or separated. So that way I'll know what the labels mean in my new variable. Okay? So I'm not going to click the change button yet. First I'm going to do my old and new values. What this is going to do is going to allow us to take the original value and tell SPSS what we want the new value for cases that have the original value to be. So we'll put in the variables the values for this variable one at a time. So we know that 1 equals married, and we're going to be removing that. That's really easy. So I put 1 for the original value, and for the new value, you notice there's not a delete button. We just want to click system missing. What this is going to do is it's going to tag that any cases that have the value of 1 as system missing, so they won't be included in any analysis. So I'm going to do that. Now I'm going to go back and look and see that 2's are recoded as a 1, and so are 3's. So my divorced and separated people are recoded as a 1. So when I go into recode, I'll type in 2 and get the new value 1. And then I will do the same with 3. 3 is recoded as 1. Okay. Next, I'm going to look at the 4's who are widowed. I'm removing them as well. So just like I did with marriage, I'm going to take 4 and recode it as a system missing value. Okay. And then last but not least, never married is a 5 or 5. So anybody that got a 5 has never been married. So I'm going to type in 5 for that value, and then the new value is going to be 0. And then a practice I like to do is after I've put in all of my actual recodes, I like to click all other values, recode as system missing. And that just makes sure that if there's any weird odd numbers in there, they just get recoded as system missing. Now, I'm going to recheck my work, and I indeed wanted to remove 1's and 4's, widowed and married people. I wanted to remove both of them. 2's and 3's I wanted to recode into the same group, so I recoded them both as 1's. And 5's I wanted to recode as 0, so they're in their own group. So I'm going to click continue there, and then click change. And it's going to tell me that this variable name duplicates an existing variable name. That's fine, I'm replacing that one anyway. So now I can click OK, and it will do my recode for me. So now what I can do to make sure that my recode worked correctly, I can click Analyze, Descriptive Statistics, Frequencies, remove the original marriage variable, put in the recoded variable, and then click OK. And if I did the recode right, my 0's, who are my unmarried individuals, should have the same frequency as the never married individuals from my marriage recode. And indeed, 83, 83, we're good there. My 1's should have the same frequency as the divorced and separated categories added together. So 43 plus 22 is 65, and my divorced or separated frequency is 65. And then my missing is 13, which should be the sum of married, which is 7, widowed, which is 5, and the missing values from the initial variable. So that's 7 plus 5 plus 1 is 13. So indeed we did this one right. So that's good. Now we have to do our actual analysis. Let me get this where it needs to be. Okay, so now that I've recoded my variable, I can actually compare some means. And I'm going to do that with an independent samples t-test, which you should recognize from the last walkthrough. And what I'm going to be doing is I'll first reset my analysis, and then I'll pull in the recoded marriage variable, and I need to define the groups. So 0's are group 1, 1's are group 2. So I'm comparing never married individuals to those who are divorced or separated. In my test variable, I'm looking at the depression scores, which are the CESD scores. So now that I've done all of that, I should just be able to click OK and have it work. So click OK, and I've got some group statistics here, so I can see that my unmarried individuals had a mean CESD score of 25.72, and my divorced or separated individuals actually had a mean depression score of 24.72. So actually the divorced or separated individuals had a mean that was 1 whole point lower than the unmarried individual. So already my hypothesis is looking really to not be in good shape. But let's just look at the means test in case. So we can tell that equal variance is assumed holds up. So as long as this number is not less than 0.05, we can safely assume that these two groups have about the same variance. But when we look at our significance value, it's 0.599. So that means our p-value for the difference between the means is not significant at all. So there is a 59.9% chance that we could expect to see a difference between those means as unusual or more unusual than what we observed. So totally busted. There's no difference that we can really even come close to saying exists between unmarried individuals and divorced or separated individuals. So this is what happens when you don't base your hypotheses in literature. You just make an idiot of yourself and then you put it on YouTube for your students to see. Okay? So now that that's over, let's test another hypothesis. So this time, I'm going to abandon the marriage thing. I'm done testing that. I'm going to look at education. So I'm going to say that among the homeless population, people who are more educated are probably going to be less depressed. I mean, I've seen that in other groups, that people who have more education tend to be less depressed. Why shouldn't that hold up amongst the homeless population? Well, there are several levels of education amongst the homeless population. So before I do anything, I want to look at the descriptives here. So I'm going to go back to frequencies, hit reset, find the education variable, which is here. Move that into the variables box. Statistics, I don't need any. I'll click OK. And now I can see that I have 1, 2, 3, 4, 5, 6 groups for education. So I want to look at some natural cut points to recode these groups, because 6 groups is a lot, especially when some of them have very, very low frequencies. So we got grade school or less and some high school, and those account cumulatively for 24.8% of the sample. And then I've got high school diploma as the probably most frequent group, yep, at 49, and that's about 30.4% of the sample. And then I've got this post-high but no college group, and maybe they went to like technical school or something like that, and they comprise 11.2% of the group. But them included with the preceding groups accounts for 66.5% of the sample. So then I'm going to look at people who have some college, which is 44 individuals, or 27.3%, and then those who actually graduated from college, which is 6.2%. So if I wanted to recode this and look at 3 different groups, I'd probably want to split this roughly into thirds and also do it in a way that makes sense. So I'm looking here and I'm thinking that some high school or less is probably going to be a good first third group, right? They comprise together about 24.8%, which isn't quite a third, but if we included high school with that group, we'd end up with half the sample, and we probably don't want that. Also, there is some research out there that says having a high school diploma versus no high school diploma has some relationship with how depressed you are. So I'm going to say that some high school or less is my first group, and that's going to be 1 and 2. And so you see here that 1 equals grade school or less, 2 equals some high school. I want to recode both of those into 1. And I'm just documenting this so that when I go to recode, I can remember what I'm recoding as what. Now, I need to figure out what my second group is going to be. So I can see the high school diploma is about 30.4%. So that could make our second out of 3 groups pretty easily. However, I'm kind of feeling weird about this post high school but no college group, because I think they're going to be different than those who've actually attended college, and they're probably more similar to those who have only a high school diploma. I don't have any research to support this. It's just a hunch, and like you're going to see in a minute again, hunches aren't always that great. But together, these comprise a larger than 1/3% of the sample. But I'm going to count them as one group anyway. Okay, so that's my second group. So I'm going to go back to my little document where I'm keeping track of this, and I'm recoding those who have a high school diploma as a 2, and I'm also recoding those who have more than high school education but no college as a 2. So they're going to be in the same group. Now that leaves this 33-ish% who have some college or are college graduates, and I'm going to consider that my at least some college group. So I'm going to go back and say that this is my third group. Okay, and then I can say that I have 3 groups. I'm going to go ahead and write down what my new variable is going to be. So my new variable, new education variable, I'm going to give the name edu recode, and 1 is going to equal less than high school, because that represents the people that have less than a high school education. 2 is going to equal high school, no college. So these are the people that finished high school but don't have any college. And then 3 is going to be at least some college. So we got 3 groups: those who did not finish high school, those who finished high school but did not go to college, and those who at least went to college. Okay, so let's go make those groups. So I'm going to go back to my data set, go back to transform, click recode into different variables. I'm going to reset, and then I'm going to select the education level variable, and I'm going to rename it edu recode. So that's going to be my new variable, and I'm not going to put the label in this time, but you can. And it's probably a good idea. So I'm going to put 1s down as a 1. Oops, I want to click add there. I'm going to put 2s down as a 1 as well. I'm going to put 3s and 4s down as a 2. And then I'm going to put 5 and 6 down as a 3. Okay, and that's going to recode my education variable into 3 groups. So I'm going to click change. It's going to duplicate an existing variable name because I practiced this earlier. And then I'm going to click OK. So now I've recoded education such that 1 equals 1, 2 equals 1, 3 equals 2, 4 equals 2, 5 equals 3, 6 equals 3, and I've recoded that into edu recode. So before I go any further, I want to go to descriptive statistics, click frequencies, and I want to compare my education recode to my original education variable. So if I look at that, I should be able to tell that these percentages match up, and I'm just going to make you take it on faith that I already checked this and it does in fact match up. But make sure you do that with your own variables once you've recoded, if you recode. So now that I've done that, I can compare these 3 groups I've created and look at their depression rates to see if they have different mean depression scores between those 3 groups. So running an ANOVA is really easy in SPSS. I'm just going to click Analyze, go to Compare Means, and click One-Way ANOVA. It's a one-way ANOVA because we're looking at one variable or factor predicting a dependent variable. Okay, so My dependent variable is going to be the CESD variable. And my factor variable is going to be education recode, edu recode. One thing you want to do usually is click options and check that descriptive box. That's going to give you the mean for each of those groups we just constructed, so you can actually see what the mean depression score was for each of the groups that we're investigating, and that should give you a way of interpreting your results if in fact your results are significant. Okay, so now we've done that, we can click OK. And first we see some descriptives. So before we go any further, let's look at those. So our one group, if you remember, was those with less than a high school education, and there were 40 of them. And they have a mean depression score of 26.25. Okay, so that's one of our groups. Then let's look at the second group, which is our people who have a high school diploma but no college. And they have a mean depression score of 24.33. So it does look like they have lower depression scores than those who have less than a high school education. So maybe we'll have some significant results. But when you look at this third group, which is those who attended college, they have a mean depression score of 26.20, which is higher than those who had no college. So that doesn't look so good. And then you can see the total, or the grand mean, which is 25.43. And so we are going to compare with the ANOVA each of these subgroups to the grand mean and look at and find out how much of the variance is explained by the difference between the groups and whether there's a significant difference between the groups. So if we scroll down to our ANOVA, we can see the between group sum of squares, which we're learning about in class this week. And the between group sum of squares is 140.530. That doesn't mean much on its own, but it's not going to mean much until we compare it to the within groups difference. Degrees of freedom are 2 because we have 3 groups, and degrees of freedom are for between groups sum of squares is equal to the number of groups minus 1. And our within group sum of squares is way bigger than our between group sum of squares. So that is not very good news for us. If in fact there's going to be a significant difference between the groups, then we're going to need to see a lot closer values between groups difference and within groups difference. And then that has degrees of freedom of 158 because it is equal to the number of participants minus the number of groups, which is 161 minus 3, which is 158. Okay, now we can see the mean squared, which is the variance, and that's here. It doesn't look good. We use that to calculate the F value. We have an F value of 0.556, which means that our between groups variance is about half of our within groups variance. And so our p-value that goes along with that F ratio is 0.575, which means there is no significant difference between the groups mean depression scores. So what that means is we cannot reject the null hypothesis that each of these groups has the same mean. So if we look back on our original sheet here, my hypothesis was that among the homeless population, the mean depression rate will differ between those with less than a high school education, those with a high school degree but no college education, and those with at least some college education. So the null hypothesis there would be that there is no difference between those 3 groups, and indeed there does not seem to be any difference whatsoever. This is totally busted, and that's kind of what happens when you don't use any literature to make your predictions. You do silly things that don't make sense. So this has been a really lengthy walkthrough, but I wanted to give you a pretty exhaustive lay of the land when it comes to doing data recodes And when it comes to doing an ANOVA, ANOVAs are really easy to do in SPSS. It's not going to be any harder for you than actually doing a t-test. And when I get your statistic reports, the first part graded, I should be able to give you some feedback and advice on how to actually do your recodes, and whether to use ANOVA or a 2 samples t-test or a 2 groups t-test. So make sure to ask me if you have any questions about how to do any of this once again, and I'll be happy to help you out.